Hello again. Here is the last demo video. We're just going to do this one problem, Truth Table 2.6 LRS 32. And again, I'd like you to follow along, so I suggest you go ahead and open up that problem. So what we want to know, is this formula a tautology? And so what does that mean? We want to know, is it true in every situation or not? In other words, is it true on every row or not? So we're going to have to check and see, is it true on all of these, in all rows, in which case it is a tautology, or are we going to find a row where it's false and then we know it's not a tautology? We don't know right away, so let's just start at the top. Let's consider, is it true when P and Q are both true? Okay, now this is a bigger sentence, and it's actually a little bit hard to read, so I'm not even going to try to. We're just going to see if we can calculate its truth value. Okay, so let's see. So down here we have the conjunction of Q and P, and we know that Q is true and P is true, so the conjunction is certainly true. Now here we have, again, the conjunction of P and Q, so both conjuncts are true, so again, true. Now here, though, we have the negation of Q and P, and here we said Q and P was true, and the negation flips the truth value to false. Okay. So far, so good. So now let's look at this. Well, this is a conjunction of P and Q and negation of Q and P. So P and Q, the left conjunct is true. Negation of Q and P, the right conjunct is false. So we have a conjunction whose right conjunct is true and whose left conjunct is false. So is that true or false? Well, if we're not sure, we can look. When the left conjunct is box, the right conjunct is circle. So when the left conjunct is true and the right conjunct is false, then the conjunction is false. So this is false. Okay, well, if the conjunction is false, let's look at the last stage. Well, this is the negation of the conjunction, and it's the negation of and the conjunction. This conjunction is false. So this is the negation of a false sentence, and the negation of a false sentence is true. So we know our formula is true. Okay, do we know whether or not the formula is a tautology? No, we don't know that it's true on all rows, so we don't know that it's a tautology. We don't know that it's false on any rows, so we don't know that it's not a tautology. So we need to keep going. Okay. So let's look here. Now we're gonna sort of cheat a little bit and be strategic. So if we look here, we see, well, not cheating, just being strategic. So here we have P and Q, and we know that P is true and Q is false. That's the row we're on. We're on the row where P is true and Q is false. So when the left conjunct is true and the right conjunct is false, when the left conjunct is true and the right conjunct is false, then the conjunction is false. So we can say false. Okay, now here's the thing. This is a conjunction, the next one up from here, and we know that this is false. Now we don't know, we can figure out, but right now we haven't told the program anyway whether or not this thing is true or false. Maybe you figured it out in your head, maybe you haven't. But in any case, we haven't told the program. Do we need to tell the program? No, we don't, not in this case. Why? Well, because we already know that this is false. And that's enough to tell us that the conjunction is false. Whenever, for the conjunction to be true, both of the conjuncts have to be true. And we already know that's not so. We already know that one of the conjuncts is false. And if we look at the truth table, we say, well, when the left conjunct is false and the right conjunct is true, the conjunction is false. When the left conjunct is false and the right conjunct is false, then the whole conjunction is false. So whenever the left conjunct is false, whatever happens with the right conjunct, if the left conjunct is false, then the whole thing is false. So we can just say false here. Oh, that's nice. We don't need to fill these in. Why? Because this already tells us that this is false, right? It doesn't matter if this comes out true, this is false. If this comes out false, this is still false because we have false over here. So we don't need to do these parts because this tells us already that the conjunction is false. Okay, now, knowing this conjunction is false, let's go to the last step. So it's a negation of the conjunction. The conjunction is false, so this is the negation of a false sentence, and the negation of a false sentence is true because negations flip the truth values. So we can say, okay, the whole thing is true. Okay. Now, do we know whether or not the formula is a tautology? No. We don't know that it's true on all rows yet. And we haven't found a row where it's false yet either, so we don't know. So let's go to the third row where P is false and Q is true. I'm going to tell you something. It turns out this sentence is true on this row. But wait a minute. Professor Struble, you made a mistake. You told us that it's true, and now it's telling you it's an error. Well, what this error message is telling us, there are two ways we can have an error message here. First is, actually, no, it's false. But if we click false, it's still wrong. So wait a minute. It's got to be one of them. But either way, we get an error message. Okay, why are we getting an error message? Because we haven't told the program, we haven't given the program enough information to determine that it's true. Here, we left some, on this second row, we left some of the these truth values not filled in, but we didn't need to fill them in because this false already told us the fact that this is false means we have a conjunction with whose left conjunct is false, and that's enough to tell us already that the conjunction is false. This doesn't matter because this tells us this is false. And then the fact that this is false means that this is true because it's just a negation. But when we look here, we think, well, to know whether or not the negation of this is true, I need to know, is this true or false? If this is false, then this is true. If this is true, then this would be false. Okay? But we don't know. We don't know what's going on. If we just have true here, let's see, can I get out of this? It's going to want to keep this true here. But the problem, even if we put that false there, the problem is, right now we know, is this false? I don't know. So we're getting these error messages not because these truth values are incorrect. They're actually both correct, the right ones. This is true. This whole sentence is true on this row, and this sentence is false on this row. But we haven't proved that yet. We haven't established that yet. We gotta go all the way up from the bottom on at least part of it. So let's look at the left-hand side. So P is false and Q is true. That means, so this is false and this is true. So we have a conjunction whose left conjunct is false. That means it's a false conjunction. And oh, now we're done. Wait, why? Well, we just said that this conjunction is false because the left conjunct is false and the right conjunct is true. So we have, that means this conjunction, it's a conjunction of this and this. Well, this we know is false. So we know this is a conjunction whose left conjunct is false. And so we know it's false. And since we know this is false, we know that this whole thing is true because the top sentence is just the negation of that, which is this, right? So the top sentence is a negation of a false sentence, and the negation of a false sentence is true. And again, we don't have to fill these in. We have to fill partially in to say, yeah, this is false, which means that this is false, which means that this is true. Okay? Do we know whether or not it's a tautology? Not yet. If the last row here is true, then it is a tautology. If this is false, it's not a tautology. So let's take a look. And let's just do the whole tree this time. Okay, so P and Q are false. Okay, then this is false. If Q and P are false, then this is false. This is the negation of Q and P. The negation of a false sentence is true. We're doing more than we need to. So again, we know that P and Q is false. So we have false, and the negation of Q and P is true. So we have false and true. False and true is this row of the truth table. The left conjunct is false. The right conjunct is true. That means the conjunction is false. So this row is false. Okay, well, if this sentence is false, well, the top is the negation of this sentence. So the top is the negation of a false sentence. And the negation of a false sentence is true. And so it's true on this row. So is it a tautology or not? It is, because it's true on all rows. So we'll say yes. Do we need to check a row? No. We only check a row when we're saying the formula is not a tautology, and we check a row where the formula is false. But there's no false here. It's a tautology. We're answering yes, and so we don't check anything, and we are done. So we've had examples now of doing this strategy a couple times. We go through and we find out the sentence's truth value in each row. And when one of two things happens, either the sentence is true in every row, like it just was, and that means the sentence is a tautology, and we choose yes. Or we have found a row where the sentence is false, and that means the sentence is not a tautology. We saw that in the previous video. In that case, in the module, we check the box next to a false row, and we choose no. So that's what you need to do. So you might find it handy to have this little handout. This is the back side of that, the truth tables handout with the negation and the conjunction on it. So you might find it handy to look at this also. So we've had some examples of truth tables. If you have any questions, do please let me know on the discussion boards. And good luck.